Hi everyone, how are you doing? I'm good, thank you. I hope everyone's doing okay. Thank you, Anna. We are going to work on the lab in a few minutes. If you want to check out the lab in Canvas, we'll start in a few minutes. Just hang tight. So check out lab 8 from Canvas, and then we'll start in a minute. Okay, so we are going to get started on lab 8 for CIS7. Thank you for attending. So today we are going to continue with our sequence and series discussion, but we are also going to program in C++. Now I have updated the homework assignment due date because students in CIS11, they mentioned that they wanted a little bit of extra time. So I wanted to extend it. So if you turn it in early, then you don't have to worry about completing it by the end of your spring break. But if you want extra time, so I'm flexible with that. So I changed the due date from the 11th to the 18th. So if you wanted to take a little bit of time, however, if you get it out of the way, you don't have to worry about it. You can enjoy your spring break. Next week, we don't have school, just a reminder to everyone. So you can have your spring break week. we are taking a spring break a little later than most schools. However, that will be nice. And then when we come back, we're going to talk about our projects and what you want to pursue. Okay. All right. So if you haven't downloaded your lab, you can go ahead and do so. But I'm going to start going over the exercises in Lab 8. So in Lab 8, we are going to work with arithmetic sequence. And this is when we looking at the formula that we previously worked on in our assignment. And in arithmetic sequence, just to remind everyone that we are going to add a constant to the preceding term so that way we can generate the next term. So the difference between the consecutive terms are always going to be that constant, or it's always going to be that same value. So if we're looking at exercise 1, it tells us that the arithmetic sequence 2, 5, 8, 11, 14, given the sequence, we would look at the D is the common difference would be 3, the difference between one value to the next. So if you're looking at the first number, which is A in our formula, and that is 2. And 2 plus 3 is going to give you 5. 5 plus 3 is going to give you 8, and so on. So if we plug in T of 1, which is A, then we would have 2. If we plug in for N is 2, then we can use the equation that's given here to calculate, which gives us 5. And then the subsequent number, we can continue with the n value for the position, which is the n value, and then including the a and the d to get the answer. So your T of n is a plus n minus 1 times d. So in the program, what you see there is that we are looking for the T of n when n is equal to 5. So we're looking at the 5th number in that sequence, and we're trying to determine the T of n value. So if you're looking at the program, we simply have our header files. So we have include algorithm, just like what we've been doing in the last few weeks. We use this STL because we're implementing an equation. Then we have input and output. So we would include IO stream using namespace std. Here we have a function called nth of AP. And this function type is integer. For the parameter, we are going to pass int a, int d, and int n. And these are the variables that go into your equations. So we would use the formula T of n is equal to a times n plus n minus 1 times d. And so therefore, we want to return, right, using that equation. Okay, so here we define a function, and our function is called nth of AP. You can name your function anything you want, but when we're looking at this program, this is the function. Then in the main, your driver code, you would then initialize what A would be, what D would be, and what the n term would be. So if we're looking for the 5th value, then you would want to put 5. Okay. So in my program, I modify it a little bit based on, the adjustment when I explained this last semester. So I would need to change this to 2 for A and D for 1. Okay. So if we base it on the screen capture, when in the main, when you see out, you simply have strings and you wanted to say the nth term of the series is, and we would call the function which returns the value that calculated for t of n. And it's a pretty simple program, right? So we pretty much hard code in our values for a, d, and n, and then we use a function to be able to implement our equation, which is a plus n minus 1 times d. And this is how you can implement this type of equation, right? So it's, you define a function, and remember we're using algorithm STL, and then in the main you would declare what each of the variable would be, and then you would call the function which returns the value from that formula. So it's going to plug things in and it's going to give you the output there. And we want to see that out. So we want to see out the value along with some strings so that way it makes sense to the user. So when we run this program, okay, it says that if we're incrementing 1, right, and if we start at 2, then the 5th term is going to be 6. Now, if we look at the actual sequence that was discussed here, your D is going to be 3. So if we make the adjustment to the program, it still should be able to give you the output as what it's designed to do. So if we change our D value to 3, because that's the common difference, right? You would be able to determine the 5th term, which would be 14. So let's try that. And your A is 2. So if we have an A is 2, but our D is 3, okay, and we're looking for the 5th term to verify. If we run this, right, it gives us 14, which checks out for what we see here, okay? And then the next term would be 17, right? So let's try that. If we are looking for the 6th term and we have A is 2 and we're adding 3 to each of the preceding term, then we would have 17 and so on. So that shows that the equation, right, is applied in this program and our function works. So for number 1, you can check that out, play with it a little bit. So put it in your IDE, and here you can include bits stdc.h like this. This is often used for C program, but in the way that you don't, again, to get around this, if you don't want to use this, you can use include algorithm, include IO stream, like what I have at the top, okay? And then we wanted to put using namespace std, and then your program will work. So the bits file, this bit stdc file, it is a catch-all. So if you want to, include everything, then you can use that header file. But if you want to be specific with the STL that you're using, you want to specify, right, different packages there, different libraries there, okay? So that's just another approach in using, right, a catch-all type of library or the header file, where in our case here, if you look at my program, I include algorithm and IO stream because we use algorithm for the equation and we use IO stream for cout. So after we put the program into our IDE, right, you can make adjustment to the program, right? You don't have to create another one. So you can use that template and then you are going to calculate, right, the 20th term for this sequence. So if we're looking at 3 is A, then you just have to change the declaration value for A, the assigned value for A. Instead of 2, we're going to make that 3. And then for the D, we can make that 5, because if you take 8, subtract 3, you get a 5, right? 13 subtract 8, you get a 5. And then our nth value is going to be 20. So with that said, we're going to make adjustment here. So I'm going to change my A to 3 and my D to 5 and my N to 20, right? And it's still an arithmetic sequence, so we can use the same equation to determine our T of N, and in this case, our N is 20. So we are going to go ahead and run this, right? And it tells me that on the 20th term, the 20th term in that sequence will be 98. Okay. Yes. So this would be something that you would do. Sarah. So after you put the program that I provided in the screenshot into your IDE, then you would adjust your A, your D, and your N, okay? So your A is going to be 3, right? Your D, we subtract, we get a 5, and then your N is 20. Okay? And so once you have your output, take a screen capture and paste it in. Then we need to verify with our calculation, right? Like I said before, the program is only accurate as its programmer. So what we would do is we would check. So after you run the program, you know that your T of N for the 20th term would be 98. So we wanted to plug that into the equation, right, to be able to verify our sequence. Okay. So here I repeat the equation again, and I specify that my A is 3 because that's the first number in the sequence. My D, I just take 8, subtract 3, I get a 5, or you can do 13, subtract 8. You also get a 5 because that would be a constant. And then I would verify, okay? And you don't have to do all of them, right? So I just want to type it out so it's clear for you. So T of 1, I would take 3, right? Applying the equation now. 3 plus 1 minus 1 times 5. That will be 0 times 5, which is 0 plus 3, which gives us 3. Then T of 2, we would then have 3, which is our A, plus 2 minus 1, which is 1. 1 times 5 gives us 5. 5 plus 3 gives us 8. So check and check, right? And then T of 3, 3 plus 3 minus 1. This is 2. 2 times 5 is 10. 10 plus 3 would give us 13. So now we can check for T of 20. So we would have 20 minus 1 times 5 plus 3. So 20 minus 1 gives us 19. 19 times 5, right? That should be 95 plus 3 would be 98. Let me double check my calculator if I did that correctly in my head. So 19 times 5. Yep. So that would give us 98. And that validates the program output, right? So after you run the program, you want to manually calculate and check your sequence to see if it's the right output. Any question? So this exercise, what I want to address is to how to implement an equation for arithmetic progression in a C++ program. And also we wanted to check to make sure that our output is tested, right? It's correct. And it's a good habit to do that because, you know, you might miss something or you might declare something incorrectly. So we can go back and take a look at our program, right? And then take a look at the output, calculate, and make sure that the output is correct. And so this type of program shows you how you can generate specific value. Now this one, it's only going to do the nth value, right? It's not going to generate the entire sequence. So if you wanted to create an entire sequence, then you have to implement container like array to store each of the value, and then you have to create a loop in order to generate, right, all the subsequent term from the first. So, and you will be able to, you can write a program like that, that's fine. But this particular program only give us T of n, where n is assigned a certain value. Any question with exercise 1? Okay. All right. Are we okay with 1? I'm going to move forward now. So along with sequence, on Monday, we talked about series, and series is the sum of that sequence. And we talk about Gauss trick, which we can use the equation to find the sum, right? Or a partial sum of a sequence, as long as it's an arithmetic sequence. So series is the sum of that sequence. So if you are looking at arithmetic series, then we can implement Gauss trick. So then the equation, I pulled this from your textbook. And then we would look at our program. So in this one, you have another function, okay? Let me pull mine up. So instead of using the bits header file, I can use include algorithm, just like exercise 1, include IOStream, and using namespace std. Okay, so let me verify and making sure. So the only thing different is I need to adjust mine. So 1, 2, and 5. So on yours, okay, you would have the n is initialized at as 5 and a is 1 and d is 2 in the screen capture, right? That's what it shows, okay, like this. So when we look at the program, we have a function sum of AP and its type is integer, and just like the last one, we would use the parameter variables here. So we would pass a, d, and n, and they're all integers. Then for this one, since it's a running sum, and I call this program a running sum, is it's gonna generate a value, then it's gonna add it, right? And it's gonna add it each time. So we have to have a loop. So you can say you need to then initialize the variable sum, right, at 0 to start. Then we're going to have a loop, and this is a for loop. And for loop, like what we talked about before, it has 3 parts, okay? It has the start, the stop, and the update. Okay, so in this for loop, what we want is we want to add, right, each of the value in the sequence so that way we have the series. So the way what we would do that is we would take the sum and then we would add, it's going to be equal to sum plus a. And for our a is going to be a plus d because we are going to take each of the preceding value and we're going to add it with the constant that will be the common difference. And we're going to return sum. Now, in the main, we would then assign the value to our variables. So we initialize n at 5. So that would be up to, so it's going to run, right, up to that. And then for the A, it's going to start at 1, and the D, the difference is going to be 2. So in this one, when we run this, we would get a sum of 25. So when it adds, it's going to start, right? And it's going to go up to n is 5. Now we simply have a cout and then we call the function, and in that we would pass the variable as we define that up here like this. Okay, so your function definition, you got to type it, but when you call, you don't have to type it, right, for C++. So that will be the end of our program. Now, looking at that example, you would then put it in IDE and test it. Okay. And then what we want is we want to use the formula to verify our output. So after we put it in, we find the output, then we wanted to validate the output by checking the with our calculation. So for the first term, we know that in the program that will be 1. Okay. And the last term that will be 9. How do I know it's 9? I would use the previous equation from exercise 1 and to determine the 5th term. Or you can add it manually, of course. So I would take a plus, right, n minus 1 times d, which gives me 9. Then I would then determine the series or the sum of the sequence. So I would take 5, which is the n value, right? The number of terms, so we'll have 5 terms. It's going to divide it by 2. Then we're going to multiply it by the first plus the last term. So here, this gives us 10. 10 times 5 over 2, that should be 50 over 2 or 25. So after you create that program, you run it, you verify it, then you check it with the calculation. And with that, what you can do is you can test it with different A value, different D, right? Like you can test the last program, the last sequence, and see what you would get for the series, and so on. Now this one, we didn't really directly implement this equation into the program, right? We simply use iteration technique to generate a running sum. And running sum is very common for a lot of the things we use, right? Like if you're looking at shopping cart program, like when people buy stuff online, okay, so that, every time that they add an item, it's going to add. So that's also a running sum type of program. And then we also need to update the tax, right, for the items that's taxable, and so on. So now you can see how to write a program that would generate a running sum output, and that we can use for series in arithmetic. Any question? Then for C, we need to change up our program, right? And we also want to calculate the partial sum of it. So first we want to change up the program, run the program, get the screen capture. Then what we'll do is we will check it. Okay. So you have to change your n value to 30. Your A would be 4. And your D is going to be 10. So when you edit, you would use A is 4 because that's the first term. Then your N is 30 and your D is 10. So I'm going to go ahead and do that. So I'm going to change up to 30. My D is 10 and my A is 4. And then I'm going to go ahead and run. So it tells me that the sum of my sequence for 30 values would be 4,470. So we can test it by looking at the equation. So first, we already have the A, D, and the N, so we can find T of N where N is 30. So with that calculation, we would take 4, which is A, plus 30 minus 1 times 10, which gives us 294. Then we would find the arithmetic sum. That would be 30 divided by 2 because 30 is the n, or the number of terms that we're working with, divided by 2 times, right, a plus your last term, t of 30. Okay, so I should have 15 times 298. So 298 times 15, which gives me 4470. So that checks out. Okay. So we have to show that the program is correct after we check. So we see that it is correct. Any question? Yes. So sequence is just a set of number that has some form of pattern, and in arithmetic sequence, right, going from one to the next number, you would add a constant. So that way there's a trend, right? You would increment each of the number by that constant. The series is the total value of all of those numbers. It's the sum. Okay. Yeah, so I think a lot of people mix them up in general, right? People say, oh, sequence and series is, they mix them up, but series really imply the sum of a sequence. You're welcome. So now you know how to write a C++ program that generates arithmetic series or a running sum, right? I know that in CIS 17A textbooks, a lot of the times you would see this type of program is you write a function and then it just keep adding, right? You use that function to add or to sum. Okay, any question with number 2? We don't have that many to do. Usually I like to keep it short so you can spend the time to kind of, look at it closer versus making you do a lot of programs, right? It's really important to really understand the very basic before you move into the complex area. Because if you don't have that, it's going to be a lot harder to write more complex program if you don't know how to approach a simple program. So what these exercises are designed to do is to show you how to write a C++ program for various mathematic concept that we talked about. Okay. And then we also use our math calculation to check, make sure that we implement the algorithm correctly. All right. So next, we are going to do another arithmetic series, but this one we are going to ask the user to enter a value that they like. Okay. So let me open my program up. So if you don't want to include these headers, right, all you need is, again, algorithm STL and IOStream and using namespace std. That's what we normally need for discrete math type of problems, right? And then if you use array or vector, then you would include those, or string, you would include those, right? But short general strings like this, you don't need string objects. So this one, straight and main, very easy. And we want to type this as double for our variable because we don't know what kind of values the user would input, right? So if you use int can give you, it's the range for the size for int is pretty big, but you might get a user to put in a very, very large value. So, or, you know, something could be also in the negative. But anyway, we can be safe and do double. And then we would prompt the user, enter a starting value. That will be your A, right? So we're obtaining the A. And then we are going to put it into A. And then we would prompt them again to enter the difference. That will be our D. And then enter the term. That will be our N. So in order to have your equation implemented, we need these three values, right? Instead of, you know, hard coded into the actual program, now we can have the user input. Then similar to the last one, what we're going to do is we are going to have a for loop. And we're going to start at A and we're going to loop it up to, right, the nth value, and we're going to increment with the difference. So this one, the for loop is written a little different than the last one, right, where we actually have the equation in here. Okay. So what you have is this equation represents what? The nth, the t of n. Okay, the t of n. So it's going to go up to the t of n. And it's going to update by using the common difference, which is d. Okay, because we don't know what that is, right, until that's obtained from the user. So you would then implement the variables into your loop. So we would then store everything to sum as we loop through. Okay. So then we would output. So here we go. So we would have a starting value. And in your exercise, after you put that program in, okay, let's test it with this one. Okay. A is 3, D is 6, and N is 23. So A is going to be 3, and D is going to be 6, and our N is 23. Okay. So unlike the last one, what it does is it's going to print, right, your sequence, and then it's going to give you the sum at the end. Okay. So this one generate the sequence, and then it gives you the sum. So the only equation that we implement in this is giving us the t of n, right? And then we still have it iterate or loop to do a running sum, and that will be the end output on the last line. So if we go back to our assignment for 3, right? Derive an arithmetic sequence and sum starting with A is 3, difference is, or D is 6, and N is 23. So you can do more than I have. So you can have T of 1 is equal to 3, right? T of 2 is, you would take 3 plus, okay, 2 minus 1 times E, which is going to be 6. So here you would have 6 times 1, that's 6 plus 3 is 9, and so on. So I'll do another one. 3 plus 3 minus 1 times 6 is equal to, so 12 to 15, and so on, right? And then the 23rd term would be T of 23 is 3 plus 23 minus 1 plus 6, or times 6, which gives you 135. So then we would check for the sum of series or the sum of the sequence. See, I messed up there. So the sum of your arithmetic sequence or your series would be 23 divided by 2 times 3 plus 135. Okay. So 138 times 23 divided by 2. 1587. And then look back in the program, right? 1587. So that's correct. And ultimately, the computer is a calculator, right? So you can create the program to give you the sequence, and then it can add everything up to give you the series or the sum of the sequence. So after you check the calculation, you run the program, you would take a screen capture. And again, we just tested with the input using this value, these values, 3, 6, and 23. Any question? Okay, all right. Glad to see that you're understanding. Okay, so that takes care of the arithmetic sequence and series. Then next we are going to move into geometric. So let me go back, and then I'm going to open up my number 4. So again, I replace, right, the bits stdc.h file with include algorithm, include IOStream, the top. And then I have using names ASTD. So in this right here, what we're going to do is very similar to the first program, right? And the second program, we are actually the second program and the third program, we are going to generate the series for the geometric series, which is the sum of the geometric sequence. So we have a function called sum of GP, and we are going to pass A, R, and N. And R is the common ratio. That's the number that we use to multiply each term to get to the next term. So we would then have its sum initialized so that way we can update it as we loop. And in this one, our for loop, we're going to start at 0. We're going to go up to n, and we're going to update using incrementing I. Careful, buddy. Then very similar to the last one, but now in this one, because it's geometric, what we're doing is we are going to have R times A, okay, instead of D plus A like the last one, we would do R times A. So we would have sum is equal to sum plus A, and A is A times R. And we would return sum. So in the main, then you would have these values. So I just want to double check and make sure that it lines up with yours. So 1, 0.5, and 10. Okay, so on yours, that was a little different than what I had. So here, we're multiplying by half. And your A is 1. And your N is 10, and your R is 0.5. So let me change this. Okay. Let's run. Okay. So when we output, we would have a 1. That can't be right. Let me see. Oh, I have float A. Oh, because it's concatenating there. There's an error on this. Float here, and then it's there. That's my fault, you guys. So this should have been float. And this should have been float. Okay. All right. So now let's check. Test the program. So we would have A is 1, N is 10, and R is 0.5 or half. So then we would do the sum is going to be equal to 1 times 1 minus 0.5 to the 10 divided by 1 minus 0.5. Okay. So we can plug this into our calculator. So we have 1. So 1 minus 0.5 to the 10. this will be +1. And then divided by a half. Okay. So it should be, because I have my int sum, so it's concatenate, it's shortening it to 1 there, but it should be like close to 2. Okay, so when you find your result here, it's like roughly 1 point something. Yeah. So Rashad said, should we be using float in the example 4 for R instead of int? Yep. And that was my mistake. I didn't change it in your screen capture. And also your sum should also be float, and then, you know, if you convert everything to, actually, we can leave the int there because you have the int n. But so if you have your sum is a float, then it gives you the decimal. Let's try that. Yeah, because it's still typing it as int. So you're gonna get a 1. But if you change your type with your function, it should give you a decimal. So you should get something like this. And then if you really want to make it, you know, you can round it up to make it like a rounded number. Okay, so your R should be a float. That's correct. But then you still run into, because when it output it, it's gonna give you the whole number because it's gonna want to make it an integer. Okay. And so it typed it as an integer at the end. So I'm just gonna put 1.99, so it's close to 2. Okay. So after you had written your program, you run it, then you check with the calculation. I give you the equation here, you plug that in, and then you provide a screenshot and your answer. And look at that, we're an hour early. But it's almost spring break, so I'm fine with having an hour extra. But I'll stick around for questions. Any question? Okay, so if you are finished with everything, then you can type your name into the chat. I wish you a wonderful spring break. And then I'll see you back here after spring break for our next lesson and lab. Okay, enjoy, have fun, be safe. Have a good night. I don't know if you still need that screen, but I'll put it back up. Okay. question?
Yeah, I had a question.
Sure.
In the program, we use I, and then we use the plus sign, and then the equal sign. What is that supposed to do? Oh yeah, and then sometimes it's I and then two plus signs.
Okay, so
On
I
line.
don't, in this program in exercise 4,
Yes.
okay, so for the for loop, right, when you trying to do increment, so the plus here, it's gonna +1 every time that it loops. So this is your post, right? So that means that it's gonna add 1 to I. So what is I? I is really an index, right? And it would start with the first one, which is at 0. Index 0 is always the first element. And then it's gonna go all the way up to n, and our n is 10. Okay. And as you do that, what you're going to do is you're going to update the index. So it's like counting 1, 2, 3, 4, 5, right? But in this case, we start at 0. So that will be 0 for the first round. And then it's going to do 1 for the next round for the I, and then so on and so on. Now, in some program that you can do a plus equal, right? That's a compound assignment operator. And compound assignment operators simply imply that you're taking that value is equal to itself, add whatever. So if I do like, I can write it like this: sum is equal to sum plus a, or I can have it, you know, the two operator combined, plus equal a. Okay. So those are called compound assignment operator. Um, and so, you can use it like this, or you can use it with the operators adjacent to each other, so that way you don't have to type that variable out again. You just do sum is equal plus a. Okay, so it skips a little step. Who did you have for CIS5?
Mr. McQueen.
Oh, okay.
And then when we had him, we had how do you say? He was having technical difficulties, so we were kind of like lost.